Oxygen sensors, also called O2 sensors, are critical components in modern cars. They measure the amount of oxygen present in the exhaust gases coming out of the engine. The engine control unit, or ECU, receives this oxygen data and uses it to adjust the air-fuel mixture. This optimization helps the engine run more efficiently. By maintaining the right air-fuel ratio, O2 sensors reduce harmful emissions, improve fuel economy, and ensure smooth engine performance. They are especially important for meeting strict emissions standards in today's vehicles. The O2 sensor sends signals to the engine control unit, which acts as the car's brain. The ECU processes data from multiple sensors to make real-time adjustments. O2 sensors help maintain the ideal air-fuel mixture. A rich mixture has too much fuel, while a lean mixture has too much air. The sensor provides feedback so the ECU can adjust for optimal combustion. A bad oxygen sensor often triggers the check engine light on your dashboard. This warning light may appear with specific diagnostic trouble codes like P0130 through P0175, indicating sensor circuit issues. You'll notice a significant drop in fuel efficiency, typically around 10 to 20% worse than normal. This happens because the engine can't properly adjust the air-fuel mixture. The engine may idle roughly or even stall unexpectedly. This occurs when the sensor provides inaccurate oxygen readings, causing unstable engine operation. You might experience hesitation or a lack of responsiveness when accelerating. The engine struggles to adjust fuel delivery due to faulty oxygen sensor data. Emissions may rise, causing your vehicle to fail smog checks. The sensor's failure prevents proper catalytic converter function. You may see black smoke from the exhaust or detect a strong fuel smell. This indicates an overly rich fuel mixture caused by the malfunctioning sensor. Oxygen sensors typically last between 60,000 and 100,000 miles, but can fail sooner due to various causes. One common cause is age and wear, where sensors degrade over time due to normal operation. Contamination from oil or coolant leaks can coat the sensor and hinder its function. Electrical issues like corroded wiring or loose connectors can disrupt sensor signals. Exhaust system problems such as leaks or damage to manifolds and pipes can cause false readings. Environmental factors like frequent short trips prevent the sensor from reaching its optimal operating temperature. The first step in troubleshooting a bad oxygen sensor is using an OBD2 scanner to read diagnostic trouble codes from your car's computer. These codes help identify specific issues like circuit malfunctions or lean conditions. To begin, locate the OBD2 port under the dashboard and connect your scanner. Turn on the ignition without starting the engine. On the scanner, select the option to read codes or scan for trouble codes. The scanner will display codes like P013 for upstream sensor issues or P0171 for lean conditions. Make sure to record these codes as they'll guide further diagnostics. Visually inspect the oxygen sensor and its wiring. Look for any signs of physical damage, corrosion, or contamination from oil, coolant, or other fluids. Check the connectors to ensure they are securely attached. Clean any minor contamination and repair any damaged wiring. Step 3 involves testing the oxygen sensor's voltage output with a multimeter while the engine is running. A healthy sensor should fluctuate between 0.1 and 0.9 volts. If the voltage remains steady or shows no reading, it indicates a potential problem. Always consult your vehicle's repair manual for specific voltage ranges. To perform the test, connect your multimeter probes to the oxygen sensor wires according to the diagram. Start the engine and observe the voltage readings. Connect the multimeter to the sensor's signal wire and ground, following your vehicle's wiring diagram. A healthy oxygen sensor voltage fluctuates rapidly between about 0.1 and 0.9 volts as the engine adjusts the air-fuel mixture. In contrast, a faulty sensor might show a steady voltage that doesn't fluctuate or no voltage reading at all. These patterns indicate the sensor needs replacement. Remember to always refer to your vehicle's repair manual for the exact voltage specifications for your particular model. To perform a rich lean test, introduce propane near the oxygen sensor to create a rich fuel condition. The sensor voltage should drop quickly as it detects the excess fuel. Next, create a lean condition by introducing extra air near the sensor. The voltage should rise rapidly to indicate the oxygen-rich mixture. A healthy sensor responds quickly and accurately. If the voltage changes slowly or not at all, the sensor is faulty and needs replacement. If the oxygen sensor is confirmed faulty, replace it with a new one. Make sure to choose the correct type for your vehicle, whether upstream or downstream, narrowband or wideband. To select the right sensor, refer to your vehicle's specifications. Upstream sensors monitor pre-catalytic converter exhaust, while downstream ones check converter efficiency. Narrowband sensors provide binary feedback, whereas wideband offer precise linear response. As electric vehicles become more prevalent, oxygen sensors are becoming less common. However, they remain essential for internal combustion engine vehicles and hybrids until fully phased out. Always consult a certified mechanic for personalized advice to ensure proper installation and avoid complications. In summary, oxygen sensors are crucial for maintaining engine efficiency and reducing emissions in traditional vehicles today.